Hello, I'm Sean.
And I'm Ashir, and we're going to explain ionization energy.
Ionization energy is the amount of energy required to remove the most loosely bound electron of an isolated gaseous atom to form a cation. If you look at the periodic table of elements, the ionization energy trend isn't as simple as it seems due to the jumps in ionization energy value. If you look at the periodic table here, the general trend is the more right and the more up you go in the periodic table, the higher the ionization energy. In simpler terms, the ionization energy is the amount of energy required to remove a valence electron, which is why the trend doesn't increase in any specific direction. This picture shows the general jumps in ionization energy based on the elements. Now Hashir will help us explain the different orbital blocks and their influence on ionization energy.
Now, this variation is due to the S, P, D, and F blocks. Each block holds a different amount of valence shells. The S block has 2 shells, the P block has 3 shells, and the D block has 5 shells, and the F block has 7 shells. So not only do these blocks vary in the amount of valence shells, but each valence shell can hold up to 2 electrons. Now there are special cases in which the orientation of the electrons will be different based on the element's location in the periodic table of elements, but that is a discussion for another day. And this is what the S, P, D, and F blocks are divided up to in the periodic table.
Now we have an example to help explain this topic. Which element has the highest ionization energy? A. Sodium. 1 electron is removed from a full 2p shell. B. Magnesium, where both electrons are removed from a full 3s shell. C. Calcium, where the valence electrons are removed from a full 4s shell. Or D. Rubidium, where 1 electron is removed from a full 4s shell. Here, the correct answer is A. Sodium, and Hashir will help understand why A is the correct answer.
So based on looking at a periodic table of elements, we can already determine that it's not a very logical choice that calcium and magnesium would give up their full 3s shells, or their full s shells. So we can cross those 2 out for now. And in order to better explain why A is the better choice, we'd have to look back at the location of sodium and rubidium on the periodic table. So now this is because the second ionization energy of sodium will be greater than rubidium due to its electrons being a shell closer to the nucleus, decreasing the distance from the nucleus and increasing the Coulombic force. Rubidium has more shielding as it contains more core electron shells, meaning rubidium will have a smaller ionization energy than sodium.